Welcome to the Tellabs Optical LAN video series, How to Sell Tellabs Optical LAN. This is the third in a 6 video series titled, When and What to Sell. The purpose of this video is to help you identify windows of opportunity for selling optical LAN, and then we'll also talk through the different variations of optical LAN architectures that can be positioned. The objectives of this video will be to provide guidance on the best timing to introduce optical LAN and recommending the proper optical LAN solution based on the customer's needs. Certainly, windows of opportunity for selling optical LAN present themselves in new buildings and renovations. During new builds and renovations, common reasons for looking at changing out a network would be to upgrade the CADX cabling, replace the workgroup switches, or upgrading the Wi-Fi. Voice switches may be transitioning to IP voice, or some new video technology is being added, such as kiosks, video screens, or entertainment outlets. Often this happens because of the density issues. In the IoT world, we can't keep up with the number of gigabit Ethernet endpoints, so we need a system that has better density or capacity. Also, new technology is a factor. A great example of this is Wi-Fi. Wi-Fi technology is evolving quickly. Equipment refreshes are happening at a quick pace. Workgroup switches can be manufactured discontinued. This is another opportunity to introduce optical LAN as an alternative. Building considerations also allow opportunities for passive optical LAN. For example, historic buildings need to limit the impact of the renovation on walls and the ceilings because it's a protected property. Challenging construction projects are also a factor. For example, modern contemporary offices are often open and shared office spaces where they don't have the walls or the telecommunication closets to hide equipment and cabling. Another example of challenging construction is buildings that are concrete and steel. The coring that is needed to run cable from floor to floor is expensive and disruptive to business. It is often difficult to build new telecom closets to take care of needed additional capacity and density requirements. Seaside tropical resorts where there's high corrosion and high lightning strikes are also ideal for optical LAN. Sprawling campuses like military bases and universities are ideal for the distance provided by optical LAN. Next, watch for corporate initiatives around security. Cybersecurity is top of mind right now with all the IT staff. Optical LAN can help make a more defensible LAN. Operational efficiencies are needed by IT staffs that are struggling with the complexities of new technology. Passive optical LAN is centralized intelligence and management and can help with that. Also consider network availability. Today's networks are always on 24/7. They need the highest level of reliability, and we can make improvements there as well. Keep an eye on environmental issues. Passive optical LAN takes less material, less plastics, less PVCs, and less energy. All of these can make tangible contributions to green initiatives. Optical LAN can make significant contributions in embodied and operational carbon reduction and net zero emissions corporate initiatives. Also, hosted and managed service delivery on large campuses is possible with optical LAN. You can have other business entities that need voice, video, and data over the same system. These can easily be passed off to those third-party businesses. Lastly, there are problem-solving situations. Long-reach passive optical LAN can stretch for 20 kilometers, making it useful in certain situations. Also, there are circumstances where you can't get access to ceilings for cabling. There are fiber cabling manufacturers that have solutions where fiber can be installed in a wall molding or hidden underneath the ceiling. We have seen cases where telecommunication rooms are so overloaded that there's thermal issues or space issues. Passive optical LAN can help there, possibly bypassing those telecom rooms. Also, though, there's contamination control. The best example is in the healthcare industry and air quality, where the cost of doing telecom renovations is disruptive and expensive in these locations. Also, there's the benefit of having both indoor and outdoor equipment. So we can easily deploy a WAP inside the building or out in the parking lot. Or we can place an IP camera inside a building or outside as well. There are many variations of optical LAN architecture that can meet the needs of your customers. We'll start with closet optical LAN. This is the exact replication of a traditional copper-based network where we take a high-density ONT and replace workgroup switches inside the telecommunications closet. The last 100-meter copper cabling drop can then be reused. The benefit is that it's a migration to passive optical LAN. Also, you take immediate advantage of passive optical LAN centralized management. A more preferred architecture is to push the fiber as deep as possible in the building and to get it as close as we can to the network devices, IP cameras, wireless access points, phones, and computers. You'll experience a better return on investment with the deep fiber solution. This is where we can bypass telecom rooms and repurpose the space for other business needs. The extended reach of optical LAN makes it ideal for campus environments. You can have an OLT in the main data center and start serving multiple buildings across an expansive campus up to 12 miles in radius. Infrastructure and asset protection is where you have alarmed, armored, and 24/7 monitored cable for the highest defensibility of the LAN and most secure. Best of all, you can mix and match these architectures across a campus and throughout a building. Let's look at these architectures a little more closely. First, let's look at a legacy traditional LAN. What you can see here is that you have equipment racked and stacked in all of the telecommunication closets and in the main data center. If you want to replicate this action on campus, it's going to be the same amount of equipment and electronics in every building. With a closet-based optical LAN, high-density ONTs can be used in place of traditional access switches in the telecommunications closet. The last 100-meter Ethernet cabling drop to all the existing devices can then be reused. In deep fiber optical LAN, we bypass the telecom closets. This can free up space for ONT powering and the passive optical splitters. Then ONTs are installed near the network endpoints. We have plenty of different mounting options for ONTs. They can go in a wall, behind a facade, inside cubicle furniture, under a desk, on top of a desk, in a ceiling or floor enclosure, or they can be in the plenum space. Then we have a campus LAN. As you're moving into a new building, you can do that by pushing out the fiber and placing splitters where you choose. You can see that we've bypassed the main data room and we've also bypassed the telecommunications closets. Another option is to take the same architecture and use redundant OLTs in geographically dispersed locations using Type B PON redundancy. You can interweave the fiber for the ultimate level of reliability. Last, there is PON infrastructure and asset protection. It's alarmed, armed, and monitored. You don't need to encase the cable. You don't need to have human visual inspection every day. And you can run those cables out of sight. So you have significantly lower operational expenses. This concludes this video. In it, we have discussed guidance on the best timing to introduce optical LAN and prescribing the proper optical LAN solution based on customer needs.